demonstrate how data science-based detections work in the SIM. So we're in Exabeam's advanced analytics where the majority of the data science takes place. And what Exabeam does first and foremost is it profiles and learns what is normal for any given user or device in the environment. And we can see what Exabeam has learned through data insights. So this is one way that Exabeam uses data science is a statistical-based approach, where we learn various different aspects of a given user's behavior. Like what types of assets do they access? How many failed logins do we typically see? We can do this against any of the log data that we ingest. So if I want to know what normal looks like for a user's VPN profile in terms of how much data they send, when they start their VPN, which countries they log in from, all of this is available through the data insights page. Once we learn that normal behavior, right, we just saw through the data insights, then as the user's logging in and interacting with the environment, we score all of the deviations of any given behavior against those insights. So I can see here, we're calling out that this is the first time that this user's accessed this particular asset. I can expand this here and we can see things like the anchor score and the anomaly factor. So the anomaly factor is a Bayesian scoring algorithm that allows us to dynamically adjust the anchor score based on how anomalous any given rule trigger or anomaly is. I can also see the full rule definition as well as the model definition on how we've actually created this data model in the backend. I can also always see the data insights. So that page I just showed with all the insights, anytime Exabeam generates an anomaly, we'll show the data insights. So you can clearly see why we're calling this the first time. This has only happened once. These are all of the normal behaviors for this particular user. So this is the statistical analysis that Exabeam does in near real time. We can also see during this remote access here, we can see under this particular anomaly, we can actually see where the Bayesian score reduces the anomaly factor. So the anchor score was 7, our anomaly factor is a 0.6, so this ends up with a risk score of 4. So this is our ability to do dynamic risk scoring on all of these anomalies. Not only do we do the statistical anomaly detection, we also have dedicated machine learning algorithms to detect specific types of threats, like personal email address identification looking for exfiltration or malicious insiders. We also have a possible pass the hash detection. So we can see here that this particular remote login here from North Korea, Exabeam has identified as a suspicious NTLM login and a possible pass the hash. And this gets a 90-point risk score. And 90-point risk score automatically makes this user notable and generates an alert. So this is yet another way that we're using machine learning and data science in order to detect very specific and targeted threats and stitch this into the holistic picture of all of the statistical anomalies in batch analytics to provide a really rich story about what is happening across all of the different dimensions of this user's behavior, from their VPN to their Windows authentication to file activity. Exabeam stitches all of this together into a nice timeline to give the analyst the story of what's really happening.